Okay, so as promised, today we're going to do a lot of practice problem. Now the first one is this warm-up problem. This one, we've done a lot of problems like it, so I definitely want you to pause this, work it out, and then unpause me, and we're going to go over it. So, in this problem, I ask you to calculate the pH of a solution that has sodium cyanide. I'm asking you to figure out the pH, but I don't give you an acid or base in this problem. I give you a solution that has a salt dissolved in it. Now, what do we have to do? We have to analyze this salt, right? So, sodium cyanide basically is made from Na plus and Cn minus. You guys agree? It would 100% break up in water into Na plus and Cn minus. Now I need to figure out where does this come from. So Na is what? Na is a conjugate of a strong base. You guys agree? Is a conjugate of what? Of sodium hydroxide, which is a strong base. So it's a conjugate of sodium hydroxide, which is a strong base. So far, so good. Now, how about Cn? Cn is what? Cn is the conjugate of HCN, right? Is a conjugate of HCN. And what is HCN? HCN is a weak acid. Is a conjugate of a weak acid. And like I mentioned before, when you're analyzing a salt, the first one, the metal, is usually a conjugate of a base, and then the non-metal, the second part, is a conjugate of an acid. Now I have sodium, I know it used to be sodium hydroxide, is a conjugate of sodium hydroxide. Cn is a conjugate of acid, the acid is HCN. So far so good? Okay. Now we said that, we mentioned this a couple times, if you have a strong acid or a strong base, the conjugate of a strong acid or strong base is going to be neutral. So a strong acid or base, their conjugates are going to be neutral. And then what we said, if you have a weak acid, then the conjugate is going to be basic. If you have a weak base, the conjugate is going to be acidic. So far so good. So HCN is a weak acid. So what can you tell me about the conjugate? The conjugate is going to be basic. So far so good. Okay, so what do I got here? What I got here, I have a neutral and I have a basic. So what type of solution am I going to have? I'm going to end up having a basic solution. I want to go over this one more time because you really got to know this for me. So when you look at salt, okay, it's easy when I give you acid or base, but it's a little bit harder when I give you a salt. When you have to look at the salt, you're going to analyze the salt, okay? Now, to analyze the salt, the first part usually comes from a base, right? The middle part comes from a base. And the second part, the non-metal part, the anion part, comes from a acid. So one more time. So when you have a salt, the first part, the metal, the cation, usually comes from the base. And then the second part, the anion, the non-metal, comes from an acid. So here I go, okay, this is Na plus, comes from a base. What base is that? Sodium hydroxide, which is a strong base. Cn comes from an acid. What is the acid? HCN, which is a weak acid. So far so good. And I'm going to write this down. I know you know it. Just one more time to make sure everyone's on the same page. If you have a strong acid or a strong base, what happens to their conjugate? They are going to have a neutral conjugate. They're going to have a neutral conjugate. Now, if you have a weak acid, what's going to happen to the conjugate? Then you have a basic conjugate, because your conjugate is going to end up having extra electron. Now, if you have a weak base, the conjugate of the weak base is going to be an acidic conjugate, because now it has a hydrogen and is electron deficient. So far so good? Okay, so don't forget this. Make sure you guys are getting this down. So what we predicted was that this is going to be a basic solution. Now let's do the math to make sure the math actually backs that up. Hopefully it does. So we said that we have NaCN, and we said NaCN is Na plus Cn minus, and we said that Na plus doesn't really do anything, is neutral, but what we really care about is we care about the Cn. Why do we care about the Cn? Because this is a conjugate base, right? Is a conjugate base because it's a conjugate of a weak acid, which is HCN. Is a conjugate of a weak acid, right? Is a conjugate of a weak acid HCN. So that makes it to be conjugate base. That makes it to be basic. Now, I mentioned this before. When you have conjugate base, you have to remember that it's going to act like a base. So I have a conjugate base is going to act like a base. So what I'm going to do now, I'm going to do a hydrolysis. When I have a conjugate, I'm going to do a hydrolysis. So let's do that. So the hydrolysis, I'm going to have Cn minus plus H2O, equilibrium constant, right? It's going to be an equilibrium equation. So we said this is going to act like a base. Conjugate base acts like a base. If this is my base, that means water is my acid. The base is going to get a hydrogen. The acid is going to lose a hydrogen. The base is going to get a hydrogen. Don't forget the basics. The acid is going to lose a hydrogen. This is what I end up having. And don't forget, the charges on this side, -1. The entire charge on this side, -1. The charges on both sides have to match. Beautiful. Well, I have an equilibrium. Every time we have an equilibrium, we have to do ice table. We're going to do ice table, okay? Initial, change, and at equilibrium. So, initially, what do I have? If you look at the problem, it says you have 0.11 molar NaCN. Now, NaCN is a soluble salt. It has 100% dissociation in water. So what that means is every single NaCl is going to break up. So if I have 0.11 molar NaCl, when everything breaks up, how much Cn do I end up with? I end up with 0.11 molar Cn minus, right? Because every single one is going to break up. And then 0, 0 at the beginning, minus X, because this is what I have. So this over time, this is going to go away. And I'm going to form some of the product. At equilibrium, -0.11 minus X, X and X. And you know that I have an equilibrium. So if I have an equilibrium, I have an equilibrium constant, right? Now when I look over here, I have OH minus. OH minus, it means it's basic, right? I'm going to need KB. Again, remember that. And I know I'm going to repeat this a couple of times, that conjugate base acts like a base, right? Even though it's a conjugate base acts like a base. That's really, really key. Conjugate base acts like a base. So I need a KB. Now, do I give you a KB in this problem? No, I give you the Ka of HCN. Can you figure out the KB? You sure can. So, how do I figure out the KB? As you remember that Ka times Kb equals Kw. You guys agree with that? Okay. So far so good. So what am I going to figure out? So in this case, Kw over the Ka, which is given to me, would give me Kb. What is Kw? 1.00 times 10 to the minus 14. What is the Ka is given to me? Look at the problem. Is 4.9 times 10 to the minus 10. Is that what we got? Yeah, that's what we got over here. So when I divide them together, what I end up getting, let me see. What I end up getting is, what do you guys get? 2.04 times 10 to the minus 5. So that is going to be my Kb value. Beautiful. So now I have a Kb value. Okay. Now remember, equilibrium is product over reactant. Equilibrium is product over reactant. So I'm going to have x squared over 0.11 minus x, and my Kb now is 2.04 times 10 to the minus 5. Okay, this number is pretty small, and whatever this x is going to be so tiny compared to 0.11. So what I'm going to do, I'm going to assume this is 0, which makes my math so much easier, right? So now what I have just x2 over 0.11 equals 2.04 times 10 to the minus 5. You are lucky that your teacher does not like math. Don't understand people who like math, but not judging. So what am I going to do? Now I'm going to solve for x. If I solve for x, what I end up getting is, what did you get? 1.49 times 10 to the minus 3 molar, right? Because we have to add molarity in the equilibrium equation. Okay, so this is good. Now, but what does x represent that is going to help me out? What x represent that is going to help me out, it means that that's my hydroxide concentration. That's my hydroxide concentration, right? So this is my hydroxide concentration. So x is going to be my hydroxide concentration, and that could help me out. So x could be my hydroxide concentration, and that could help me out, because remember what we said before. We said to figure out the pH or pOH, we need hydroxide, we need hydronium concentration somehow. So now we're back in business, because I can figure out the pOH, because pOH will be minus log of hydroxide concentration, right? So I can easily figure out the pOH. pOH would be minus log of 1.49 times 10 to the minus 3 molar. Every time you have OH concentration, figure out pOH. That's the best way to do this. So then what I get is 2.82. That's going to be my pOH. But I need pH. But that's also okay, because you remember that pH plus pOH equals 14. So all I have to do, subtract that from 14. If I subtract it from 14, I get 11.17. That is going to be my pH. Alright, the moment of truth. Is that what we expected? This is a basic pH. This is pretty basic, right? What did we expect here? We expected a basic pH, didn't I? Yeah. So we expected a basic pH, and we got a basic pH, right? So is basic as expected. Cool. Yeah, you got this down? Beautiful. Ready for next problem. Okay, next problem you should easily be able to do. Which solution has a high pH? Now in this problem, I give you 3 salts. I ask you which one is going to have a high pH, which means which one is going to have a basic pH. But I don't give you any numbers, so I don't need numbers. In this problem, we figured out number, and it's going to be basic. But we could have done this without figuring out the pH. So tell me which one is going to have a basic pH. So you have to analyze the salt. You have to analyze each salt. Okay, let's analyze the first salt, ammonium bromide. Okay, ammonium bromide. Let's see what's going on with the ammonium bromide. Okay, again, we said the first one usually comes from the base, the second one usually comes from the acid. So the first one usually comes from the base, and the second one usually comes from the acid. So where did the ammonium come from? Ammonia is what? Ammonia is conjugate of ammonia, which is a weak base. Okay, so ammonium is a conjugate of ammonia, which is a weak base. Now Br is conjugate of HBr, right, which is a strong acid. You'll find that again. The first one usually comes from the base, the second one comes from the acid. I look at the Br, I was like, okay, Br, if I add an H, it would be HBr. So this is a conjugate of HBr. Ammonia is a conjugate base of ammonia. Okay, so ammonia is a weak base. If you're a weak base, what happens to your conjugate? If you are a weak base, your conjugate is going to be acidic, right? So what that means is this is going to be acidic. Now, if I have a strong acid, HBr is a strong acid, what happened to my conjugate? Strong acid or base, they have a neutral conjugate, right? So now this is going to be neutral. All right, so I have an acidic part, I have a neutral part. What is going to be the pH? The pH is going to be acidic for this one. You guys follow that? Okay, beautiful. Now, next one. Pause me. Do the next one on your own to see how you do. So lithium and carbonate. Lithium is a conjugate of what? Is a conjugate of lithium hydroxide, right? Is a conjugate of lithium hydroxide, and lithium hydroxide is a strong base. You guys agree? Okay. Carbonate is a conjugate of what? Is a conjugate of carbonic acid. Is a conjugate of carbonic acid. Carbonic acid is a weak acid. Okay? So, lithium comes from lithium hydroxide. That's a strong base. Strong base, their conjugate would be neutral. Now, carbonate comes from carbonic acid. Is a weak acid. If you have a weak acid, it's going to be basic, right? If you're a conjugate of weak acid, you're going to be a conjugate base. Conjugate of weak acid is basic. It's going to be conjugate base. I have neutral and I have a basic. What am I going to do? My pH is going to be basic. All right, we're almost there. KCl. Again, the first one usually comes from a base. The second one comes from the acid. If you look at a K, K is what? Is a conjugate of KOH, right? That's going to be the base. Cl is a conjugate of HCl. Beautiful. So conjugate of KOH. KOH is a strong base, right? What is a strong base? The OH with a 1A group metal and bottom of 2A group metal is considered a strong base. We talked about it in a previous lecture. Make sure you understand that. So, conjugate of a strong base. Again, KOH is a strong base. If I have a conjugate of a strong base, I am neutral. Beautiful. Now here, conjugate HCl is also a strong acid. So, conjugate of a strong acid is also neutral. So, if I have KCl in the solution, what's going to be the pH of my solution? Is going to be neutral. It's going to be a pH of 7. Yeah? Okay. This was a big problem. So again, the first one usually comes when you're analyzing the salt. The first one usually comes from the base. The second one comes from the acid. To decide what base and acid it comes from. And then if they come from a strong acid or base, the conjugate is going to be neutral. If they comes from weak acid, the conjugate is going to be basic. If they come from a weak base, the conjugate is going to be acidic. And then decide what you got. Okay, nice job. Nice job. So I think we've done a lot of practice problems with the conjugates and all that. So hopefully you guys are getting this down.